and this is a little video for my year 8s for revision. So here we go. Friction, really important. It's a force that acts opposite to whichever way you're trying to go. So if your little shoe is trying to go that way, friction will act and it will go backwards, like so. So it's like a really awkward force, but it's very useful. Without it, you won't be able to walk on the ground. It'd be like walking on ice. It makes toilet paper work, pretty gross. It makes wheels work on your bike. So it's a pretty useful force, even though sometimes it cannot be that good. So let's have a look. We did an experiment, and our experiment was the idea that we had a plate, and onto it we were putting weights like this one, and we wanted to know what effect of pushing down, what effect that would have on the amount of friction that would act on the table. So, to find out, we did the following. We had a piece of string, we had a wheel that just got rid of the rubbing, there it is, and to be able to pull it this way, we attached little weights on the end, slotted masses they were called, like little discs. Now, there's a clever little trick. If we go back a few lessons, there was this equation. Weight is mass times gravity. So if we want to pull very gently on the string to find the force, if we put some masses and times it by 10, which is gravity, we can find very accurately the weight, which happens to be a force. It's a force. So by putting masses on something, you can apply a very weak force. And we did. Each one of those discs, if you remember, was 10 grams, which, if you do the maths, is 0.1 newtons. So we want to find this force here, friction force, and to do it, it's a bit like tug of war. We want to find this number here, so we gently start pulling this way by adding on the slotted masses. And once we've hit the right amount, it'll start moving very slowly in this direction. And at that point, we've found the friction that was acting on the plate. Results, pretty easy. Here we've got our force down, and we went up in ones, 1 Newton, 2 Newtons, 3. And on this side, we did the hard version. We did friction. But imagine instead we did the easy version and we just counted slotted masses. Alright, really easy, no maths. And let's do an example, 3, 5 and 7. And what we can say then, really, it's obvious, isn't it? That if we look in this direction, as we increase the amount of force, the number of slotted masses required to make the dish move went up. And what that means is, more slotted masses means more friction force, because the two are linked. And that'd be quite a nice little sentence if you're watching this video to learn. I think it would help you. Anyhow, if you have any questions, you've got until Tuesday to come and ask me. You know where I am, and good luck. Bye bye.